Okay, I'm going to be going over the practice test. We'll start with the multiple choice. Unit 1. And let's go through each question. So for question number 1. The 35th percentile of a population is a number such that percentiles are always at or below. It's not necessarily normal, but for the sake of our brains, let's use a normal curve. So 35th percentile is the number at which 35% of the people score that value or less, whether it's a measurement or score or whatever. So in this question here, 35% of the population scores equal to X. No, it's that number or less. 65% of the population scores are above X. Well, let's see. 1 minus 100% minus 35% is 65%. So if 35% are at or below that value, then that would mean that 65% would be above that value. So it's going to be that one. Question 2. It's a good idea to try these problems first before I go over them. So if you're just doing this with me, take a minute to pause it, put an answer down, and then you can watch my video and you can repause it and unpause it and see if it matches what you got, okay? That helps you learn a little bit better. A standardized score describes. A standardized score is a z-score. So that's the, a z-score is how many standard deviations above or below the mean. Mean minus 1 standard deviation. So how far a particular score is from the mean, how much skew there is in a distribution, how far apart the mean and median of the distributions are, how far a particular score is from the mean, how much spread there is in a distribution, or excuse me, how far a particular score is from the median, no. How far a particular score is from the mean, yes. Z-score doesn't talk about spread, that's the standard deviation. Doesn't deal with the medians, deals with the mean. How far apart the mean and median are has nothing to do with z-score. How much skew there is, nothing to do with z-score, but how far above or below the score is from the mean. It's 1 standard deviation above, 1 standard deviation below. So if a z-score is 1, it's 1 standard deviation above the mean. If it's -1, it's negative, it's 1 standard deviation below the mean. And any decimals in between, obviously. Okay, number 3. Jack and Jill are both enthusiastic players of a certain computer game. Over the past year, Jack's mean score when playing the game is 12,400 with a standard deviation of 1,500. So Jack's mean and standard deviation are given here. And let me write those down. Jill's mean is 14,200 and a standard deviation of 2,000. See what I'm doing? I'm just writing it. Haven't even looked at what I have to do, but I know that I'll be needing to use those. So it's always a good practice just to jot them down as you're working through them. They devise a fair contest. Each one will play the game once. They will compare z-scores. Jack gets a score of 14,000. So his score is 14,000. And Jill gets a score of 16,000. Now Jill scores higher, but that's not the point of the game. The point is to compare how well they did to each other based off of their own values. So with Jack, he's going to do, Remember, z is x minus the mean over standard deviation, so 14,000 minus 12,400 over 1,500. And Jill is going to be 16,000 minus 14,200 over 2,000. Take a moment to crunch those numbers. Okay, for this one, I'm getting 1.06 repeating. And then for this one, I'm getting 0.9. If they're comparing z-scores, Jack has the higher z-score. Even though he had the smaller number, he did better than he normally does. So Jack's is 1.07. And Jill's is 0.9. Jack wins because his z-score is higher. Question number 4. IQs among undergraduates at a Mountain Tech are approximately normally distributed. The mean undergraduate IQ is 110. About 95% of graduates have IQs between 100 and 120. Excuse me. So your mean is 110. And about 95 have their scores between 100 and 120. Now let's remember the empirical rule. 68% within one standard deviation. 95% is within 2 standard deviations, and almost all, 99.7%, are within 3 standard deviations. So that 100 and 120 are actually 2 standard deviations out. So there's going to be a middle number there. You're going to have a 105 and a 115. So that's counting by 5s. All right, that 5, 5. So that standard deviation would be 5. Question number 5. This one's a lot of words. The risk of an investment is measured by the variability of the changes in its value over a fixed period, such as a year. More variation from year to year means more risk. The Government Securities and Exchange Commission wants to require mutual funds to tell investors how risky they are. A news article, New York Times, April 2nd, 1995, says that some people think that the proposed risk descriptions, especially one that goes by the daunting name standard deviation, are hard to understand. Explain to a friend what the standard deviation means, using the fact that the changes in a mutual fund's value over many years have a roughly normal distribution. Whew, I'm tired reading that. But let's just think about what standard deviation means before I even address the questions. Standard deviation is, on average, how much something is, a point is above or below the mean, okay? Just think about that. Now we're talking about a normal distribution. So we would say within 1 standard deviation above and below the mean, it's approximately 68% of the stuff. Within 2, it's approximately 95. And within 3, it's approximately 99.7. Let's see if we can answer this question. The standard deviation is the largest change we ever expect to see in a year. Standard deviation doesn't deal with one data point, it deals with multiple. So there are many years, not just 1 year. The standard deviation is the distance between the lower and upper quartiles, so it spans half the yearly changes in the fund's value. The standard deviation doesn't have anything to do with quartiles. The yearly change in the fund's value will be greater than the standard deviation half the time and less than the standard deviation half the time. That's not how standard deviations work. Standard deviation is on average how far 1 year or one data point is from the mean. So it doesn't necessarily going to fall like that. Start with the average, the mean change in the fund's value over many years. The actual change will be within one standard deviation of that average in about 68% of all years. According to the empirical rule, within one standard deviation, both above and below, that should be 68%. So that would actually be true. The last one, start with the average, mean change in the fund's value over many years. The actual change will be within one standard deviation of that average in about 95% of all years. Well, that would be 2, not 1. So it's going to be this one. That was definitely the wordiest one. Let's go on to number 6. A company produces ceramic floor tiles that are supposed to have a surface area of 16.0 square inches. Due to variability in the manufacturing process, the actual surface area has a normal distribution with a mean of 16.1 and a standard deviation of 0.2. So your mean, 16.1, standard deviation 0.2, it's normal. The proportion of tiles produced by the process with surface area are less than 16.0 square inches is, so your goal is to find out if your mean is 16.1, what is the proportion that's going to be less than 16? Well, already I hope you realize it's going to be less than 50% because 16 is below 16.1, right? But the standard deviation is going to determine what that percentage is. And I'm going to go right to the calculator. I'm not going to use the table, but I will show you how to use the table too. We'll use an 83. It doesn't matter if it's an 83 or 84, but on the 83, go to second vars, normal CDF, and the lower bound is your first number. So everything below a number, all the way till negative infinity, you would say -1, second comma for the E, 99. That's negative infinity, lower. And then the upper comma would be the cutoff point, 16. Your mean would be the next number after the comma, which is 16.1. That's your mean. And then your standard deviation would be your last number, which in this case is 0.2. So as you can see, the percent under the curve from 16 is about 30.85% or 31%. So it's going to be this one. Now, of course, we could have ruled out that one because that was too high. But the other ones were kind of in play because we really don't know, what that standard deviation is going to do. If you were to use the table, then you can also do it like this. You have to get a z-score though. So the z-score would be 16 minus 16.1 divided by 0.2. And I'll calculate that real quick. The z-score ends up being -0.5. So on the table, and I'm just going to get my table here. So -0.5. And you're going to use this number because the top column doesn't have any numbers after the 5. So it would be 0.3085, same number that we got from the calculator, but just a couple more steps because getting the z-score and looking at the table is going to take a little bit more work. Question number 7. Let X denote the time taken for a computer link to be made between the terminal in an executive office and the computer at a remote factory site. It is known that X has a normal distribution with a mean of 15 seconds and a standard deviation of 3. On 90% of the occasions, the computer link is made less than. So what is that value here such that this shaded area to the left of it would represent 90% or 0.9 of the curve? Know that your mean is 15 and your standard deviation is 3. What is that number? Well, we know it's going to be more than 15, right? We can rule that out. But beyond that, we need to use some technology. So this is going to be an inverse norm. So for the inverse norm, do second vars. Go down to the third option. The area for inverse norm is always the area to the left of the curve. So we're going to put 0.9 in. And then you're going to, after that, it's going to be comma, the mean, which is 15, comma, the standard deviation, which is 3. So that gives you 18.84 seconds. So that's what this value is. So that choice. Let me show you on the table. So on the table, you'd want to do a z-score. Sorry, that is a, let me erase that. So you don't know your z yet, but you do know that the mean is 15 and the standard deviation is 3. But we can get our z because on the table, you're going to look for 0.9. So 0.9 is going to be right about, I would say that's the closest number to it. 0.8997, super close. The hundreds place is going to have an 8 there, and if you follow that over very carefully, it should take you over to 1.2, so 1.28. All right, so your z-score is going to be 1.28, and then we're going to solve that for x. And we just solve it by multiplying by 3 and adding 15. So 1.28 times 3, and then plus 15, and there's your 18.84. Question number 8. When you're looking at a normal probability plot, a normal probability plot would be considered normal if it's more of a straight line. This one is not a straight line. What this ends up looking like is you're going to have a bunch of data points here, and then you have potentially some skewness going on here to the right, okay? So normal probability plots the numbers against z-scores, not against anything else. So it's going to be skewed to the right because of this tail going to the right. It may have outliers. These points could be considered outliers, but It's not normal. It is skewed. It probably does have outliers, so it can't be this one. It's not approximately normal, and it's not even symmetric. It's going to be skewed right, so it's going to be this one here. Question 9. Different writers have different styles. One way to quantify this difference is to compare the distribution of word lengths in their work. Below are parallel box plots describing the distributions of word lengths for the first 60 words in Harry James's The Turn of the Screw, J.K. Rowling's Harry Potter and the Chamber of Secrets, and Chapter 1 of your statistics textbook labeled Starnes below. Based on the graphs, which one of the following statements must be true? 75%, let me annotate here, 75% of the words in Rowling's distribution are longer than the median word length in Starnes' distribution. Well, let's look at the median word length in Starnes. Now the top 75% of Rowling's would be here, Rowling. And as you can see, there are some below that number. So that's not going to be the answer. The range of Rowling's word length is smaller than the interquartile range of Starnes' word length. Well, her range, include the outlier, that range is from approximately 1 to 9. So that range is equal to 8. The interquartile range of Starnes is from 2 to 6. So that is going to be 4. So that's not true. It's got a bigger range than the IQR there. The longest word in the distribution of Rowling's word length is shorter than 25% of the words in James's distribution. The longest word for Rowling is going to be what appears to be 9. 25% of the words in James would be this whisker here, which there are some words that are shorter in here than there are for Rowling's longest word. So that is not true. Dot plots of the distributions of James's word length and Starnes' word length are identical. Just because you have the same box plot, what appears to be similar, doesn't mean that all the values are going to match up. Okay, there could be a value here, there, and there, but there might be values here, there, and there. Okay, so those aren't always going to be identical. The median word length for Rowling's is longer than for either Starnes or James. So here's Rowling's median. Here's James's, and here's Starnes. And you can see that that is a little bit higher than those two. So it's going to be the last one here for me. And one more, I believe. The distribution of lengths of salmon from a certain river is approximately normal with a standard deviation of 3.5. If 10% of salmon are longer than 30 inches, which of the following is closest to the mean of the distribution? All right, so 10%, probability that X is larger than 30 is equal to 10%. We are given the standard deviation, but not the mean. There are a couple ways to solve this. First thing I'm going to do is I'm going to reverse that. So the probability that X is less than 30 would be 90%. Okay, so first think about it going the other way. 90% are less than 30. Now we can do a z-score. So we know that we have to get z first if we're doing that. So we can go to our table or our calculator. I'll show you both ways. So with the table, we're looking at 90%, 0.9. I think we've looked at this before. 0.9 is 0.8997. I think it was 1.28. 1.28. On the calculator, you can get that number. We'll do the 83 for 83ers by doing second var's inverse norm. And to get the z-score, you do 0.9, comma, 0, 1, because you're using a standard distribution, standardized scores. That's going to make the mean 0 and the standard deviation a 1. There's your 1.28. So now that we have z, so z is going to be at that point 1.28. So we can use the formula z is equal to x minus the mean over the standard deviation. We can plug in everything. Remember, we're trying to find the mean. We don't know the mean, but we do know this is 1.28. We know that x is going to be 30, and the standard deviation is 3.5. So I would solve this first by multiplying by 3.5. So that's going to be 1.28 times 3.5, which is 4.48. So if I add the u to 4.48, and then I can take the 4.48 from 30. The mean is going to give me 25.52. So the question says which is closest to the mean. Well, that would have to be 26 inches. Now you can do this by guessing and checking as well. First, you can do the inverse norm. And keep your area at, remember, since the 10% above, that area is still going to be 90% because we're subtracting that from 1. Remember that the area above is equal to 1 minus the area below. So this is where the 90% comes from. Sorry, that's really sloppy. But by guessing and checking, you can eliminate using the z-score formula. So if you have the area 0.9, you don't know your mean, but you got some choices. Let's say I did 34, and my mean was 3.5. My goal is to get that as close to 26 as possible. Or excuse me, my goal is to get that as close to 30 as possible. And you see how 26 does give me about 30. But if I were to do that with the other answer choices, let's say I made 34, that's too high. And let's say I made that 28. Too high. And you can see the other ones are going to be too high, but this one is going to be closest to 30. Even another way would be to do the normal CDF. You would make your lower bound 30 because the original question was above 30, you'd make your upper bound infinity, 1e99. You would guess and plug in your mean. So if we plugged in 26 in our standard deviation of 3.5, we would want that percent to be about 10%. And 10% seems not too close to that. So let's check the other ones. Let's say it was 34 we checked. Well, that's even way off. Let's check 28, 33, and 30. That's too high. That's way too high. And 30, well, that's going to be 50% because 30 is the same as that mean there in that case. So it would have to be, even though we don't have something super close to 10%, this number would be the closest to 10%. So 26 is still the closest. And you remember how we got the answer of 25.52. So if we actually change that to 25.52, that would get us 10%. Okay, but this rounds to 26 because they're giving you whole numbers. That was a long and winded explanation of that problem, but you get the idea. And hopefully that was helpful for you. Thank you for watching.